Any questions from your homework or about the class before we do notes? Okay. We're on 2.2, limits. Notation. The limit as x approaches a of the function f of x is equal to L. Okay, and so writing this down, it says the limit as x goes to a, or x approaches a, is equal to L. So I put quotes around this A because I'm talking about that letter A, not, so it's this symbol here. So x approaches A of f of x Okay, so A is some number, this is your function f, and then you get some, usually some number value, or we'll talk about other possible things that could be L, but we're going to start with an example. So as x is,
what does wait x to a? Why is it not x to y, and why is it x to a?
the picture, a graph will help. So I'll show you on a graph, but just to read this one more time. As x gets arbitrarily close to a, f of x approaches and gets arbitrarily close to L. Let's just write that down. So I've got just a function that kind of swoops around like this. I'm going to go through the origin, come down, and back up. Right here, we'll go over and mark that side as -2. then right here at this peak, we're going to remove that value, and the output right here will be actually at this 2, and it goes to 1. So you have the 0.21 and then a hole right here. Okay, so what we're going to do is have our x values get arbitrarily close to 2 from the right side and from the left side. Right limit as x goes to 2. Of this function, we're going to call it f.
Kathy, I can't hear you.
Okay, I'll try to speak louder. I'm going to mess around with a microphone today too. Okay, the limit as x goes to 2 of f of x is equal to, does someone want to guess before I explain? Oh, actually, sorry, I didn't mark a number there. We need 1, 2. Okay.
So 5.
So the x values are getting closer and closer to 2, and the f of x values are getting closer and closer to 5. And on the right side too. Going f of x values getting closer and closer to 5. Doesn't have to actually equal 5, it's just very close to that number. You're approaching that value. Okay. Let's do the limit as x goes to 4 of f of x. Then someone take a guess. Okay, the same. X is going towards 4. On the left side and on the right side, your function values are, or your outputs are going to get closer and closer to -2.
Negative.
Yeah. Let's do one more. Let's do the limit as x goes to 5 of f of x. So x values are getting closer to 5 on the right
0.
and 0. And then on the side, we're going to put that the function actually sends the x value of 2 to 1. But when we talk about limits, we're talking about the value you approach, not the value that the function is equal to.
So are we just looking for maxes and minimums?
Not yet.
Not yet. Okay.
We're looking for where your function's getting closer to as you approach some certain x value.
Okay. 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 That makes sense. Thank you.
Sends 2 to 1. Okay. So I've mentioned that we were approaching on the left side, the left side and the right side. So you could have a one-sided limit. You approach from the positive side or the negative side.
Wait, I don't understand the no. What do you mean by no?
I think it can't get.
Oh, what do you mean by the no? F2 equals.
Your function sends the value of 2 to an output of 1, but the limit at x equals 2, the value that your function approaches at 2 is
Oh,
simply 5.
okay,
It's kind of like going with this part here.
okay. Got it.
All right. The limit as x approaches a from the left you put a minus sign right here as like your exponent, I don't know, or superscript of your function f of x is equal to L. And we'll write this down. The limit as x goes to a on the left is equal to, of f of x is equal to L. And it's this a. As x gets arbitrarily close to a from the left, f of x gets arbitrarily close to L. I put closer on a just to make it look like it's not a word, it's that symbol right there. But you don't have to put quotes around it, that's just me. Okay. From the left. Okay, and then we talk about approaching a from the right. The limit as x approaches a and you put a plus sign as a superscript from the right of f of x is L. And again, the limit as x approaches a from the right. So it's not from the right of f of x, it's approaching a from the right. So maybe it would help to put parentheses around the from the right part. And then you talk about your f of x. And it's some value L. Okay. As x gets arbitrarily close to a from the right, f of x gets arbitrarily close to L. For this function, we're going to draw the graph, get everything labeled, and then find some limits. I'm going to go over to 5, 4, and there's going to be a hole. And then the function is going to curve down through the origin. And then at 5, 0, there's a point, and then the function goes up like this. And I call the function f. So this is a piecewise function. F is this piece and this piece. So it goes over and comes straight down and continues up. Okay, let's do the limit as x approaches 5 from the left. of that function f of x. Okay, first I want someone to take a guess. X is coming this way. Where's your function going?
3.
Thank you.
Wait, the 3 comes from the white. Wait, where does? Oh wait, 3 comes from 5, x equals 5 and negative. Oh, okay. I think. Okay.
So
I
these
think I
ones
see.
closer and closer to.
So yeah, so if x is going to 5 to the right, then it might be 0, right?
Yes.
Yes. Okay. Write that down.
That's a place. Okay. So it said limit as x goes to 5 from the right of f of x is 0. Okay. So since the limit on the left is not the same as the limit on the right, this is what we say. The limit as x approaches 5 from both sides of the function f of x does not exist. I write, and other teachers have seen use the same thing. DNE, it stands for does not exist. Or you can write this all down if you want to, does not exist.
Wait, why it doesn't exist?
Because they're not equal to each other. And that's going to come from the theorem we're going to write down next. But if they don't match on both sides, then you say that it doesn't exist.
Okay.
That's called the two-sided limit theorem. To have the limit at x equals a, both the left hand and right hand limits must exist and be equal. Like equal to each other. the limit as x approaches a of f of x will be equal to L as only, or if and only if, the limit from the right as x approaches a of f of x is L, and the limit from the left as x approaches a of f of x is also equal to L. So you'll see this a lot in your math classes. If and only if means that this implies the next statement, and that statement implies the one before it. So it goes, this is true if that is true, same the other way around. Okay. We're going to start drawing a graph. We're going to call the function f. Right, label 2, 4, 6. We're going to have a -2 and a -4 here. And then I've got 1, 2, 3, 4, 5. And the function is going to go through 0, 2 and come over to 3, 6. Then we're going to have a opening, or let's see, a hole at 5, -4. And connect. And we're going to pass through the point 4, 0. Then at 5, 6, there's a point. And then we're going to curve just down. And then all of this is my function f. Okay, we're doing limits. Let's have x approach 3 from the right. So the limit as x goes to 3 from the right of f of x. This way towards 3. Where's your function going? Somebody.
is it like 6? Isn't that the same thing with 3 to the left or something?
Yes. And then
Okay.
we'll put that, we'll write that down.
Yeah.
So the limit as x goes to 3 from the left of your function f of x is also 6. And since they both exist and they're equal to each other, we can say that the limit as x goes to 3 from both sides is 6. Okay. Let's do the limit as x approaches 5 from the right. Somebody want to share what you think it is? Let's say for your x values, your function is getting closer and closer to
6.
6. Awesome. All right, let's approach 5 from the left.
I have a question.
Oh.
How many limits can you have with one function? Is it like unlimited? Or is there like a typical number?
You're gonna get either some number or that does not exist, or we're gonna talk soon about having it be infinity or negative infinity.
Okay.
Those are kind of your options. Okay, and then from the left. As x goes to 5. And what do you think it is?
-4.
Negative 4. So this limit from the right exists, and this limit on the left side exists. It's this number, but they don't equal each other. So the limit as x approaches 5 from both sides does not exist. Again, DNE is does not exist. Okay. With limits, we're looking at the behavior of a function around a point, not right at the point. So you get closer and closer to some x value, but not actually equaling that value. Okay, I have kind of an answer to the question that was asked of what can you expect for your limit. I have a couple cases. Case one. Fix this. So sometimes the limit as x approaches a of your function f of x is actually equal to the value that f sends a to. It's equal to some output from your function, which is f of a. Okay, I have an example. We're going to look at f of x being x squared. So let's sketch this parabola. I'm going to label the point 1, 1. And the limit as f of, the limit as x approaches 1 from the right of f of x. So then you're getting closer and closer to 1 for your x values. F of x values are getting closer and closer to 1. Also, well, we have the same thing on the left as x approaches 1 on the left. F of x approaches 1. Since they're both values that are equal to each other and the number 1 exists, then the limit as x approaches 1 from both sides is 1.
So x to 1 is just 1. It does exist, right?
Yeah, and f does send 1 to 1. If and only if is abbreviated like this IFF. So it is a word, or it does mean something. It's not a misspelling. IFF is if and only if. Limit f x goes to 1 of f of x. Awesome. F of 1. So put 1 through that function and you get out 1 squared, which is 1. We're going to look at this again in another section. The other case is where f of a does not exist. Okay, so I've got this function. It's f of x equal to x squared minus 1 divided by x minus 1. Remember we talked about not dividing by 0, so we cannot have x equal to 1, because if this was a 1 and you minus 1, then you divide by 0. So we're going to draw the graph. And x equal to 1 will not be in our domain. Also, you can check these graphs using like Desmos or Wolfram Alpha, but I'm pretty sure I've checked my sketch. It's just a line. We're going to go through the point 0, 1, and there's a hole at the point 1, 2, or where there should be a point 1, 2. That's my function f. So the limit as x approaches 1 of f of x would be equal to 2. So just instead of putting the symbol f of x, I'm going to replace it with its actual like outputs. You can put either one. You can put f of x. We can put this part. I'm going to use this part. And it's equal to 2. X is coming this way, and your values go towards 2. That way. Values go. Let's put in x equal to 1 through that function f. And then you'd get out 1 squared minus 1 over 1 minus 1. And that's a 0 over 0. Any number divided by 0 is undefined. Also, sometimes you'll see, I'll write it down. Undefined or does not exist. I just want to give a reminder that for all non-zero numbers x over x is equal to 1. But for 0, it's not the case.
Wait, same equation, right?
This is
Same.
just on the side.
Okay. Yeah, but we're still using the same equation, x squared minus 1 over x minus 1. We're still using that equation, right?
This function, yeah. Or
Okay, yeah.
for that function f, it's this function here.
Okay.
And I'm only saying this because sometimes people will see 0 over 0 and they think, oh, number over number equals 1. Like 2 over 2 is 1. Negative 4 over negative 4 is 1. But it's not true for 0. If you have a 0 over 0, it's undefined.
Okay.
Okay, and I think we're just about out of time. I'm going to write down what the third case is. And next time we'll come back and do an example.
Okay.
Case 3. The limit as x approaches a of f of x is not equal to f of a. I'm going to show you what the example is, and then when we come back, we'll draw the graph and we'll look at the limits. Or we'll look at a limit. The function looks like, well, the function is a piecewise function. First piece is sine of x for x not equal to pi over 2. Other piece is to have negative 3 when x is equal to pi over 2. All right, okay, next time we'll draw this graph and we'll look at the limit as x approaches pi over 2. But we're done with class for today. Thank you, everybody.